see. Thank you. Okay, Rema, welcome. Welcome. Good afternoon, guys. Good afternoon, everybody. I hope you guys are doing very fine. Okay, so this is another day for physics. For those of you joining for the very first time, this is Green, and I'm your physics tutor here at Tuteria. We started our classes like 2 days ago, free dope classes, where we started with dynamics. We looked at the different tricks, the different shortcuts that can be used to solve so many questions in dynamics. We moved on to optics yesterday, where we looked at refraction of light. I explained to you the concept of optics, what is optics, the meaning of light, and the idea behind the fact that we have what we call electromagnetic waves and the electromagnetic spectrum. I explained to you that light is just a portion of that spectrum that the human eye can see, that the human eye can actually detect. So we did all of that yesterday. I gave you some questions to solve yesterday as well on refraction of light. Make sure you practice those questions. One thing about UTME is you cannot just get a very good score overnight. Like it's not by magic. It's not a miracle. You have to put in the work. You have to practice continuously, and that is why we are here at Tuteria, because we are not just going to be teaching you. We are going to be helping you practice the right way, because there are different ways you can practice. You can practice in some type of way that will not yield the best result. But here at Tuteria, we understand the rudiment. We understand everything that has to do with gaining success, getting very good score in UTME and even beyond UTME. But now, for you guys, we are focused on UTME. We have experienced tutors. We have been teaching this program for over 10 years. So we know everything as regards physics, everything as regards mathematics, everything as regards chemistry, English language, biology, all the courses. So you can just trust us to help you get that very good score um, in your program. Okay, so yeah, like I said yesterday as well, these are just free classes, and that is why we are just coming up to just teach you one or two tricks, teach you one or two topics. It is not the actual program. Our proper program is starting on Monday. Demola Factoria, your math tutor, mentioned it. Lucy, your English language tutor, mentioned it. Dr. Jan also mentioned it. I am also saying it again that our program is starting on Monday. It's a full-blown program to prepare you adequately for UTME, for your exam. So you cannot just bank on this 1 hour class or 50-minute class of just one topic and expect 320 over 400. No, it does not happen like that. You must follow the process in full. So we are starting on Monday. If you are yet to register, make sure you register. Tell your parents. You have seen us already. You have seen some of the tutors. Of course, we still have the biology tutor. We have, if you are taking what's it called? If we have, for those of you that join the English language class and you are not a science student, that means that you have friends that take government, that take history, that take IRS, CRS. We have tutors for all of these subjects. So you should register with us at tuteria.com/UTME for you to get the full package. We are ready for you guys. So let's just move on to what we have for today. So today we'll be looking at a very interesting topic, a topic that you cannot escape in your exam. It is always there. In fact, even beyond UTME, when you gain admission into your various university or polytechnics, you will still come across this topic. It is very important. In fact, some individuals that will study some physical science subject like maybe physics or chemistry will still take this particular topic in higher level. 200 level, 300 level. So that means that you need a proper foundational knowledge of this topic beyond UTME. So, and what is that topic? We are looking at photoelectric effect. Look at this man here. Can you tell me who this is? Can you tell me who this is? Photoelectric effect. This is the famous man, Albert Einstein. Now, he did not discover photoelectric effect actually, but he made it popular. In fact, he enabled us to be able to study it and understand it properly. That is why I'm having this picture here, because he's a very great scientist. Photoelectric effect, what is it all about? A German physicist discovered this effect here. His name is Hertz. That your unit for frequency. Yes, that unit for frequency. I'm sure you have seen this spelling before. This man in 1887 actually discovered photoelectric effect, but scientists at that time really do not understand what it means, because at that time we are focused on things that are visible to the human eye. That is what they can really explain in physics. But it was now later, maybe about 20 years later, or less than 20 years, in 1905, that Albert Einstein now worked on Hertz experiment again and was able to explain it in full details. In fact, 16 years later, he won an award for that his explanation, and the equation he gave us, that special equation that helped us to solve questions every day in photoelectric effect, it was given by this man. So it is a very essential topic in physics and even beyond physics. In science generally, this is very essential. So the first thing is, what exactly is photoelectric effect? From the word photoelectric effect, photo has to do with light. So when we say photo is basically light. Electric, of course, that means I can say maybe electricity or maybe electrons. Then effect is an occurrence, yes, something that happened. So what is photoelectric effect? So the idea of photoelectric effect is the fact that when we have a material, so let me just go to the diagram to explain it. Look at the diagram I have here. This diagram is everything photoelectric is talking about. If I have a metal, look at that metal guy. Inside the metal, we have what we call free electrons. So these guys are free electrons. We have electrons inside all metals. So all metals are made up of free electrons. Now, it was discovered that when light, that is a radiation, when it is incident, when we say incident, meaning when it strikes a metal surface, it is very possible that these electrons that are embedded inside will be ejected out of the metal surface. That is what photoelectric effect is all about. Photoelectric effect is the libration of these electrons from the surface of a metal when radiation is incident on that metal surface. That is what photoelectric effect is all about. Libration of electrons when light is incident on the surface of a metal. It's as simple as that. But if you look at this diagram, we call this ejected photoelectron. And inside of this metal, I said that these electrons are just free electrons inside the metal. When they come out, we call them photoelectrons. So get the idea. We have electrons inside the metal. Now, when this light is incident on the metal and the electrons are able to come out, those electrons that are liberated, that are ejected out, we now call them photoelectrons. Reason being that they are being ejected because of light. If this light is not incident on this metal, these electrons will not come out. So when they come out, we call them photoelectrons. So photoelectric effect generally is the emission of electrons from the surface of a metal when light is incident on that metal surface. It's as easy as that. However, we need to have a very solid understanding of this concept again. Okay, that's good. Yeah, Albert, you are welcome. Well, this is not everything. Like I said, this is not everything we have for you guys. We have a full package. Yes, Ernest, we have a full package for you guys. and you just have to join us to experience this. And the good thing is this: you are not just the fee is 35,000 naira for the full program. If you check around your area, there is no tutorial you can attend that will charge you that amount for 3 months or even 3.5 months. It's not possible. So you are paying 35K and you even have the chance to win prizes every week. You are going to be giving quiz, what's it called? Practice questions every week, and the highest person will get prize. Beyond that, if you can get the highest score, if you can get the highest score in this year's UTME, Tutorial has a special package for you. What's that package? You can actually win 2 million naira in scholarship together with a laptop. That is mind-blowing. That's huge. Imagine you are learning to gain admission, you are learning to get knowledge, and at the same time, you are getting prizes. You are getting reward for what you are supposed to do normally. So tell your parent, it's beyond just preparing yourself for UTME. You have the chance to win prizes. You have the chance to win 2 million naira for the first person. There's 1 million naira for second, 500,000 naira with laptops. So we have prizes from the first to up to like the 10th person, depending on your performance in UTME. So tell your parents about this. It is just 35,000 naira for the full program. Most tutorials out there will charge you 20,000 naira per month. Now we have 3 or more months and we are charging just 35,000 naira. So you have to key into this offer. It's like a very sweet offer, I will not lie. Let's go back to our class. So we understand that photoelectric effect is the emission of electrons from the surface of a metal when light is incident on that metal surface. However, you must understand some key terms in photoelectric effect. So let's look at some key terms in photoelectric effect. Key terms in photoelectric effect. Now, the first term is or let me call it key terms and facts in photoelectric effect. Now, we said that photoelectric effect is the emission of electrons from the surface of a metal when light is incident on that metal surface. Are we now saying that immediately light is incident on that metal surface, no matter the type of light or no matter the strength or the energy of that light, electrons will be emitted just like that? No. There are some conditions that must be satisfied before this effect can occur. And those conditions are what we are going to discuss in these terms. Now, the first guy that I'm going to talk about is what we call the work function. Work function. We use this symbol to represent it, phi. Sometimes in your text, in your textbook you use in your class, in your school, they can use W. It's fine. But phi is the special symbol for work function. Phi, as in P-H-I, phi. Work function. What exactly is work function? Now, these electrons, let's go back to the diagram. These electrons are embedded inside this metal. They are inside this metal. Without this radiation, they cannot go out. They are just inside. Just imagine that there is a boy that mistakenly fell inside this pit here. He's inside the pit. This is the level ground here. This is the road. So the boy is inside the pit. The electrons are inside the metal. This boy cannot go out unless maybe there is someone that will throw him a rope to pull him out, or maybe we use something to carry him out. The electrons are inside this metal. Now, how can this electron just come out of the metal and be at this surface here? How can we help this boy to come out of the pit and stand outside here? The minimum energy that is required to just liberate these electrons, to just bring out this electron from here to this surface here, is what we call the work function. The amount of energy that is needed to help this boy to just come up here is what we call the work function. So the work function is a property of the metal we are dealing with. Each metal with its own work function. If I have calcium, it will have its own work function. If I have cesium, it will have its own work function. And what is work function again? The minimum energy that is required to just liberate, meaning to just carry these electrons from this inside to this surface here. That is what we call work function. Now, work function is the energy. So that means that it's measured in joules. Take note of that. Sometimes in your question, they can give you this work function in what we call electron volts. Generally, energy is in joules. That is the derived unit for energy. But then we can also be given in electron volts. So work function, even the photon energy and the likes can be given in electron volts. You must remember that 1 electron volt is equal to 1.6 times 10 raised to power minus 19 joules. That's the relationship. That is the relationship between electron volt and joule. So sometimes I might need to convert. Take note, I will tell you when you need to convert. This is the relationship between electron volt and joule. That is number one, work function. The minimum energy that is needed to just carry these electrons that are inside, to liberate them, to make them escape from inside to outside of the metal. I hope that is very clear. Okay. All right. Now the next term or the next concept that we'll talk about is what we call the threshold frequency. Threshold frequency. Number 2, threshold frequency. Sometimes we also call it the cutoff frequency, or we also say the critical frequency. Threshold frequency. What is the threshold frequency? Now, the first thing you must know is the fact that this light that is coming, this incident radiation that is coming from here, has an amount of frequency. It's coming with a particular value of frequency. Remember, if you're in my class yesterday, I told you that light is a region of the electromagnetic spectrum that is visible to the human eye. And that electromagnetic spectrum, what are they again? The radio wave, the microwave, the infrared, visible light, ultraviolet ray, X-ray, and gamma ray. All of them, they all have their respective frequency value and wavelength value. So this light that we are talking about, it has a particular frequency value as well as wavelength value. Take note of that. So when this, let's say this is a light source that is incident on this metal, this light source has a frequency value and also has a wavelength value. Now, what is now threshold frequency? Threshold frequency. Threshold frequency is the minimum frequency. The minimum frequency or the lowest frequency required for photoelectric effect to occur. The minimum frequency that light must have before these electrons can be liberated from that metal. What are we saying? Let's assume the light that is coming from that our source has a frequency of 10 raised to power 15 hertz. That is the frequency that our light has. Now, that metal that we are working with, let's say this is the metal here, will require that light to have a minimum amount of frequency. That minimum amount of frequency is what we call the threshold frequency. So we denote it by F naught. So our light is coming with this frequency, but our metal will require a value for the frequency. So let's assume that this metal requires 10 raised to power 16 hertz as the minimum frequency that the light should have. But our own light is coming with 10 raised to power 15. If you compare 10 raised to power 15 and 10 raised to power 16, which one is higher? 10 raised to power 16 is definitely more than 10 raised to power 15. That means that the light that is coming does not have sufficient frequency for that light, for the electrons to be emitted. So what we are saying in essence is that before these electrons can be emitted, the frequency of the light must not be less than the threshold frequency. If the frequency of the light is less than the threshold frequency, photoelectric effect will not occur. Once the frequency that the light has is less than the threshold frequency, meaning the minimum frequency that metal requires, then this effect will not occur. For photoelectric effect to occur, then the frequency of our light must at least be up to the threshold frequency. This is what will make the effect to occur. So threshold frequency is the minimum frequency required for this effect, for the emission of electrons from the surface of a metal. I hope that is very clear. Okay, if you have any question, you can just drop it down there. Let's move on to the next. The next guy is threshold wavelength. Before I now go to the Einstein photoelectric equation, threshold wavelength. Now, there's a relationship between frequency and wavelength. Remember yesterday I gave you this equation that V equals to F lambda, our popular wave equation, the relationship between velocity of the wave, frequency, and wavelength. Now, I also mentioned that all our electromagnetic waves, the radio wave, blah, 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 the radio wave, infrared, and the light, they all move with the same velocity. And that is in air, which is the speed of light in air, which is denoted by C. So if we replace this V with C, that's C equals to F lambda. Now, if I make lambda subject of the formula, that means lambda will be equal to C over F. So that means that if we can have frequency, if I know frequency, automatically I should know wavelength. There's a relationship. Wavelength is equal to C, which is speed of light in air, 3 times 10 raised to power 8 meter per second over the frequency. So let's now go back to what we call threshold frequency. So that means if there is threshold, let's go to what we call threshold wavelength. If there is threshold frequency, there should be threshold wavelength, because wavelength and frequency are related. So, but what is the kind of relationship you can see here? Is it a direct relationship or an inverse relationship? Lambda equals to C over F. C here is a constant. You can see that this means that lambda is inversely proportional to frequency. So, if threshold frequency means the minimum frequency, if threshold frequency is the minimum frequency needed for photoelectric effect to occur, then what will now be threshold wavelength? Since wavelength and frequency are inversely related. Inversely related means that if frequency is going down and gets to the minimum, then wavelength should be going up and get to the maximum. You don't have to cram, you just need to understand. So we explained threshold frequency to be the minimum frequency needed for photoelectric effect to occur. The minimum frequency that light must have before electrons can be emitted from that metal. And we know that if frequency is minimum, automatically wavelength should be maximum. That means that threshold wavelength will be the longest wavelength, highest wavelength, maximum. But remember yesterday I also mentioned that for wavelength we use long and short. Instead of saying high and low, we use long and short, because length, now don't forget, it's a length. Length can either be long or short. So if threshold frequency is the minimum frequency needed for photoelectric effect to occur, then threshold wavelength will be the longest wavelength for photoelectric effect to occur. It will be the opposite of what threshold frequency is. It's as simple as that. So the question might not say calculate threshold wavelength. They might say calculate the longest wavelength for photoelectric effect to occur. We should just know that they are talking about threshold wavelength. Calculate the longest wavelength, that means threshold wavelength. Calculate the minimum frequency for photoelectric effect to occur, that means threshold frequency. Take note of this. It is very important. And calculate the minimum energy needed for photoelectric effect to occur. That means they are talking about the work function. It's as easy as that. It's as simple as that. Okay, I have registered for JAM. Okay, that's good. That's good, Mike. That's good. All right, so let's move on to the Einstein photoelectric equation. So how do we solve problems in photoelectric effect? So I told you in 1905, which is that 1905 is an amazing year for this man, the young scientist back then. In fact, we call this year the miracle year. The miracle year. Yeah, for him, he did a lot of work. He wrote a lot of paper, and his work on photoelectric effect stood out. If you remember this equation in physics, we have seen it before in your school. E equal to mc square. Have you seen this before? Is that popular equation by this same man. However, it is his work in this field, the equation I want to show you now, this equation that he gave us that won him the Nobel Prize in 1921. So what is this equation? Let's see the equation. Let me wipe this and let's see the photoelectric equation, the Einstein photoelectric equation. We use this equation to solve problem. This equation tells us so many things about the photoelectric effect. So this is it. Let me start from the diagram. The same diagram. I have the metal. I have electrons inside the metal. Light is incident on this metal, and we said the electrons will be ejected. This is the incident light. Incident light. All right. Now, the photoelectric effect equation as given by this man, Albert, is that E equals to phi plus Ke max. That is the equation. E equals to phi plus Ke max. What is E? E here is representing the energy of the photon. So when I say photon, I mean the radiation, the light that is incident on that metal. So that light is coming with an amount of energy, and that energy is denoted by E. Now, how can we calculate that energy? Sometimes we might not be given. Remember, I also told you that that light has an amount of frequency and also an amount of wavelength. Now, that frequency and wavelength are related or can be used to calculate this energy if you don't know the energy. Meaning, the energy of that light is actually E equals to HF. What is H here? H here is called the Planck's constant. Planck's constant. And the value is around 6.63 approximately times 10 raised to the power minus 34 joule second. That is the Planck's constant. So the energy of the radiation, this E is the energy of the radiation, it is equal to HF. What is H? Planck's constant. What is F? F is the frequency of that radiation. Frequency of radiation. So Einstein is telling me that, okay, the energy of that light will be equal to phi. What is phi again? Our work function. Now, before I go to work function, remember this equation that we have up here, that light can have either frequency or wavelength. So if I'm not given the frequency, I can be given the wavelength. What's the relationship between wavelength and frequency? Frequency is equal to C over lambda. From C equal to F lambda, right? Up there. So if frequency, let me write it here. If C equals to F lambda, that means F will be equal to C over lambda, the wavelength. That means I can say the energy is H. Instead of F now, I can put C over lambda. So there are some questions that they will not give you frequency. Instead of frequency, they will give you the wavelength. So the energy is directly proportional to the frequency. That means the higher the frequency, the higher the energy of the light. But the energy is inversely proportional to the wavelength. That means the longer the wavelength, the lower the energy. The shorter the wavelength, the higher the energy. Now, the next thing we have in the equation is phi. What is phi? Phi here is our work function. And there's also a formula for work function. Work function is the minimum energy needed for you to bring out those electrons. And it is related to the threshold frequency as well as the threshold wavelength. Work function is actually HF naught. And it can also be HC over lambda naught. What's lambda naught? Did I tell you that lambda naught is a symbol for threshold wavelength up here? Okay, I did not mention it. Just like the threshold frequency is F naught, we use lambda naught to represent threshold wavelength. So our work function, the formula for calculating work function is HF naught or HC over lambda naught. What is that C? That C is 3 times 10 raised to power 8 meter per second, the speed of light in vacuum. If you have any question, let me know before we now begin to solve problems. If you have any question, let me know. Drop it in the comments. Drop it there. Okay, let me go back. No question. All right, so E equals to 5 plus Ke max. So what is this Ke max? Ke max here is the maximum kinetic energy. The maximum kinetic energy of the photoelectrons. Maximum Ke of the photoelectrons. What are the photoelectrons again? They are the electrons that are emitted when light is incident on a metal. So those electrons that come out when light is incident on a metal are the photoelectrons. So what is this equation really saying? The equation is saying E is equal to 5 plus K max. E is equal to 5 plus K max. Let me go back to the boy in the pit to explain this equation. So we said if we have this young man in this pit, he mistakenly fell in this pit, the minimum energy that is required to bring him up here is the work function, right? Now, imagine that that boy is so scared, he just wants to come out of the pit and run away and just go. So that means that the first thing he needs to do is what? Be able to come out of the pitch. Then he will now what? Move with a velocity to go to his house. Or maybe his dad is around and just took him, carried him in his car and they went home. So that means that we have two situations here. We need to take this boy from inside this pit to this platform, to outside of the pit. And also, it also needs another amount of energy to now what? To now go home. So that means that the total amount of energy we are going to be giving this boy, which is E, a portion of that energy must be sufficient to bring him out of the pit. That is our work function. Then another portion, if we still have an energy that is left, then the remaining energy should now what? Be used to take him home, which is Ke max. So the sum of these two will be the total energy that we are supplying the boy. Now let's come back to the metal. That's just the idea. Let's come back to the metal. So we have the metal. This is the metal here. We have the incident light. The incident light is coming with an energy E. The metal has a work function phi. So we are saying that the amount of energy supplied, the amount of energy of that incident light supplied to the metal should be able to overcome the work function. Sometimes we call the work function the potential barrier. It is a barrier that is holding those electrons, a surface barrier rather. The surface barrier that is holding those electrons, that is impeding those electrons, stopping those electrons from coming outside. So the energy of that light must first off supply that surface barrier, and if we now have more, if we have extra energy, then the remaining one should now be used to what? Should now be used by the photoelectrons to move, meaning it should be converted to kinetic energy of the photoelectrons. So let's now make it more practical. Let's assume this light is coming with an energy of 100 joules. This metal has a work function of 95 joules, meaning that before I can allow, the metal is saying before I can allow electrons to come out, before these electrons can be liberated from me, you must supply me with 95 joules of energy. And the light we are using is 100 joules. So that means that if I give the work function what it needs, which is 95 joules, I will still be left with 5 joules. What would these 5 joules now do? That 5 joules will now be used as the kinetic energy of those photoelectrons. So the photoelectrons begin to move with different velocity with the remaining 5 joules. That is what Mr. Einstein is. That is what he's just saying here. That the energy of the incident radiation should always be equal to the work function of the metal plus the maximum kinetic energy of the photoelectrons. That also means that, let's assume that the work function is still 95 joules, but I supplied an amount of energy of say 95 joules as well. So that means that the work function will just take my entire 95 joules, right? And we'll be left with 0. That means that the electrons will just come out of the surface. They will not be able to move. There is no kinetic energy in that situation, but they will be liberated to the surface of the metal. So for them to move with an amount of velocity, with the energy of that radiation must be more than the work function. So Ke max in this formula is the maximum kinetic energy of the photoelectrons. Now, and of course, how do you find kinetic energy again? Of course, you remember from your primary school that kinetic energy is half mv square. So that kinetic energy can be gotten using half mv square. But there's a problem, there's a challenge. Let's now talk about this final part, which is stopping potential, where I will now talk about that challenge. Stopping potential, before we now go to our questions. So what if I want to stop these electrons from moving? Oh, I am in the laboratory. Look at the setup. We have a vacuum chamber. We have 2 plates. We have a metal. We have another plate, which is the detector. We have a battery connected. Look at that. We have the ammeter, which is used to measure amount of current. So this is the light. It is incident on the metal. If the frequency of that light is up to the threshold frequency or even more than threshold frequency, the electron should be what? Liberated, and you can see from the diagram that the electrons are liberated and they are moving towards this positive plate here. Why is that plate positive? Look at the battery. We connected this positive leg of the battery, to this plate here. That is why this plate here is positive. And the negative leg of this battery is connected to the negative leg here. Negative leg here is connected to negative. That's why this guy here is what? Negative. Now, what if I want to stop these electrons from moving? I want them to just remain on the surface of the metal. I want to stop photoelectric effect. What will I do? And that is what we call stopping potential. So the only way we can stop the photoelectric effect is by applying what we call a potential, a voltage. Let me come down. A voltage that will impede or that will oppose, that will counter the kinetic energy of those electrons. Remember that immediately this light is incident on this metal, then the electrons, and that light is sufficient enough, the energy of the light is high enough, meaning the frequency is more than or equal to the threshold frequency, the electrons will be emitted. Now, I want to stop the electrons from moving. What will I do? I will apply a potential. In fact, I will apply a negative potential. To this plate. I will apply a negative potential to this plate. Remember, electrons are negatively charged. So when I apply a negative potential to this plate and a positive potential to this second plate here, if I apply a negative to the plate where the electrons are going, that means that there will be an electrostatic force between the electrons and that particular plate. The electrons are negative. I apply a negative potential. Let me wipe this a bit. Okay. All right. So if I apply a negative potential here, it will create an electrostatic force of repulsion because electrons are negative, and I apply negative potential here. So that means that there will be a force of repulsion between the electrons and this plate, meaning that the force here will be pushing back the electrons. The force will be pushing back the electrons to a level whereby the electrons will just remain on this plate here, meaning that photoelectric effect has stopped. Now, why do we have the ammeter here? Now, as the electrons are moving, as these photoelectrons are moving in this chamber here, we are going to be seeing the reading on the ammeter here that, there is current that is flowing. Remember, electric current is the rate of flow of an electric charge. Electron is an electric charge. So when electron is flowing in a conductor, in a conducting material, current will be produced. And how do you measure that current? We use an ammeter. So that is why we have the ammeter here. So the ammeter is what is measuring current. And the type of current that we have in this situation is called the photocurrent. Photocurrent. Why? Because the current is obtained from photoelectrons. So the current is called photocurrent. So in order for me to stop this electron from moving, I will apply a potential Vs. Here, a negative potential Vs. Now, the minimum potential Vs here that is now needed to stop this electron from flowing is the stopping potential. Meaning that the amount of energy, the amount of potential, electric potential energy from this battery that can counter the kinetic energy of the electrons is what will give us the stopping potential. So the stopping potential is directly related to the kinetic energy of the photoelectrons, meaning EVS. So this EVS here is our electric potential energy. So the battery will have an electric potential energy. The electric potential energy of the battery of this our setup here will be equal to the Ke max. So this is another formula for Ke max. Ke max is actually equal to EVS. What is VS here? The stopping potential. The potential that is needed to stop the entire process. And what is E? E is our electronic charge. E is 1.6 times 10 raised to power minus 19, the charge of an electron, minus 19 coulomb. So the Ke max, so when the kinetic energy of the electron is balanced by EVS, the electrons will stop moving and there will be no current that will now flow again. Okay, let's go to questions. I think we have explained so much already. Okay, so what is the value of the longest threshold wavelength? It depends. It depends on the metal you are considering. It's not a constant. So if I have metal A will have its own threshold wavelength. If I have another metal B, let's say this is another metal, this one will also have its own threshold wavelength. Do you understand? So that is the idea. It depends on the metal and it varies from metal to metal. Let's go to questions here. Let's go to questions because of our time, so we can wrap up. Let's go to questions here. And in the questions, I will be doing a recap. Someone requested for a recap. I will do a recap. Now look at this first question here, UTME question, basic question. And I did not mention this. I purposely did not mention this while I was doing my explanation. Look at the question. It said, the time taken for a photoelectron to come out after the photon strikes a metal is approximately dash. Photon in this case is talking about our incident radiation, our incident light. So what is this question? The question is, if this is a metal, we now have our radiation, it strikes this metal. How long will it take those electrons that are inside? How long will it take them to come out? Now, photoelectric effect is an instantaneous process. Instantaneous process. Instantaneous process. Meaning that the electrons should come out immediately. There should be no time lag. There should be no time delay. Once the light is incident on the metal and the energy of the light is high enough, meaning the frequency of the light is not less than the threshold frequency, then the electron should come out immediately. There's a value to it, but in experiment, we realize that it will take the electrons 10 raised to power minus 10 seconds. If you cannot put this in your head, remember this is the same thing as 100 picosecond. Pico is 10 raised to power minus 12. So in some exam, you can see it as 100 ps. P means pico, P-I-C-O, and pico, just like nano, milli, centi. Pico is 10 raised to power minus 12. So it will take the electron 10 raised to power minus 10 seconds. What's 10 raised to power minus 10? 0.0000000, about 9 zeros, then 1 seconds. That's very short. So the electrons more or less come out immediately once the light is incident on them and the energy of the light is sufficient to liberate these electrons. So take note of this. Take note of this. Photoelectric effect is an instantaneous process. There is no time delay between the what's it called? There's no time delay between the incidence of that light and the emission of the electrons. Take note of that. I hope that is very clear. I hope that is very clear. Okay. You said you don't understand what stopping potential is. I have a question on stopping potential. I will explain again when I get to the question. You said, let me just mention it again. Stopping potential is just the voltage. The voltage that can be used to stop electron from moving. That's it. That's just it. What is the amount of voltage that will help me to stop this process? What is the process? Emission of electrons from a metal. So how can I stop these electrons? I need an amount of voltage. I need to connect an amount of voltage to that metal. That amount of voltage, the minimum value of that amount of voltage that is needed to stop this process, to stop this electron from being emitted, is what we call stopping potential. From the name, stopping potential voltage. So the minimum potential and voltage are technically not the same, but for the sake of UTME, let me just use them interchangeably. Stopping potential is just the minimum amount of voltage that is needed to stop electrons from being emitted. That's just it. Let's go to the next question here, because of our time. So look at question 2, a very simple one. They say calculate the energy of a photon of wavelength 250 nanometer. Energy of a photon. Photon is just our radiation, our light. So what are we given? We are asked to find the energy, and we are given the wavelength. Lambda equals to 250 nanometer. So how do you find the energy? What's the relationship between energy of the light, of the radiation of the photon, and wavelength? I've given you in this class that energy is just hc over lambda. And what is h? 6.63 times 10 raised to the power minus 34. What's c? Times 3 times 10 raised to the power 8 divided by let me I'm not getting the indication again. Okay, yeah, divided by lambda. What's lambda? 250 nanometer. What's nano? 10 raised to the power minus 9. So this is 250 times 10 raised to the power minus 9. You cannot use nano, you have to convert. So that's 250 times 10 raised to the power minus 9. If you punch this in your calculator, if you are there, punch your calculator, punch with me. Punch with me. Let me punch mine here too. If you punch your calculator from there, we have the options here. So we have 6.63. Remember, you will not have access to scientific calculator. So that means that you have to be very solid with your knowledge of what's it called? Standard form, how to work with indices. So just do 6.63 times 3 under your local calculator, times 3, then divided by 250. Divide by 250. If you have done that, you should get 0.07956. Then 10 raised to the power minus 34. Work with the indices that we have here. We have minus 34. We have 8 over minus 9. So if I combine this 8 and minus 9, remember this division here. That means you add. It will be 8 plus 9. That's 8 minus 9. That's 17. So I have 10 raised to the power minus 34 plus 17. And what is that? That should give us minus 17. So this is times 10 raised to the power minus 17 and joule. But if you look at the options are in electron volt, EV. So how do you convert from joule to electron volt? That is why I gave you that relationship, that 1 electron volt is equal to 1.6 times 10 raised to the power minus 19 joule. So to convert from joule to electron volt, you will divide by this value. Divide by this value. To convert from electron volt to joule, you multiply by that value. So if I say 1.2 electron volt, convert it to joule, what will you do? You multiply by 1.6 times 10 raised to the power minus 19. But if I say 20 joule, convert it to electron volt, you divide by 1.6 times 10 raised to the power minus 19. So here I will divide by 1.6 times 10 raised to the power minus 19, and I will get my result. So if you divide, work at home and divide this by, again, you just divide by 1.6 here. So if I divide by 1.6, I have 0.0497. Then if I now combine this minus 17 and minus 19, don't forget again to be minus 17 minus 19. That will be plus, and that will be 2. So that will be times 10 raised to the power 2 electron volts. 10 raised to the power 2 is 100. So that means I will shift this guy twice. 1, 2. So that means at the end of the day, this E, this should be, okay, this is in joule. At the end of the day, the energy, I think I have space down here, the energy is just 4.97. So we have 4.97. We have 4. Where is the guy? Okay. The guy is not sensitive again. Let me. 4.97. I will check E equal to 4.97 electron volts. That's option B. Is that clear to everybody? Okay, let me go to the next question. Next question. Question 3. Question 3 here. I have the work function of a substance is 4 electron volts. So we are given the work function 4.0 electron volts. The longest wavelength of light that can cause photoelectron emission is approximately dash. What is that longest wavelength called? Longest wavelength that can cause photoelectric emission. I told you that is just the threshold wavelength. Threshold wavelength. So that means in this question we are looking for threshold wavelength. Now, anytime we are given energy, maybe energy or work function, and you are asked to find frequency or wavelength, you must remember that your energy must always be in joules before you can find frequency or wavelength. When I say energy, don't forget that work function is also an amount of energy, the minimum energy. So if you are giving your energy in electron volts and you are asked to find frequency or wavelength, you must ensure you convert that energy to joules. So what is the relationship between work function and the longest wavelength? What is that longest wavelength again? Threshold wavelength. What's the relationship? Phi equals to hc upon lambda naught. So if I make lambda naught subject of the formula, it will come here, phi will come down, lambda naught will be hc over phi. So I will just insert my value. I will leave you to do this completely. What's h? 6.63 times 10 raised to the power minus 34 times c is 3 times 10 raised to the power 8 divided by 5. What's our 5? 4 electron volts. But don't forget, you must convert to joules. And what did I say? Electron volts to joule. You do what? Multiply by 1.6 times 10 raised to the power minus 19. So this one will be 4.0 times 1.6 times 10 raised to the power minus 19. You do the math, the answer should come out in meter. You tell me what the answer will be on the what's it called? In my on the comments in my social media platform. Go to my IG, or go to the YouTube channel. Yeah, watch this video again and drop the answer to this particular question. Just punch your calculator and get the answer from there. So let me move on to the next. Okay, now the next question. So we have, I'll give you some as assignment. Let me just solve 1 or 2 more and we call it a day. Okay, is there any question here? Okay, no one is. Okay, so we have look at this question here. Not all the questions in photoelectric effects will be calculate. Your understanding of the concept is also important, and in fact your understanding of basic things in mathematics is very important. Look at this question. They said according to Einstein's equation, the plot of kinetic energy of the emitted photoelectrons from a metal versus the frequency of the incident radiation gives a straight line whose slope is dash. Look at the question, it's not calculate anything. A, slope depends on the nature of the metal. B, depends on the intensity. C, depends both on this and all. So the question is about energy, the kinetic energy versus frequency of the light. Kinetic energy versus frequency of the light from the equation. Now let's write the equation again. What's the equation? E equals to phi plus Ke max. Now we need the frequency of the light. Don't forget, from E we can get frequency of the light. So if I make Ke max subject of the formula first, it will be equal to E minus phi. Now, because the question is the plot of kinetic energy versus frequency. So that is why I'm making Ke max subject. Let it be here first. Now, if I continue with this, Ke max will be equal to, what is our E? E is same thing as HF minus phi. Now, they said the plot. That means that I can compare this equation I have here to the straight line equation. The plot is a straight line. They said it's a straight line. Now, what's that popular straight line equation that you know? Y equal to mx plus c. So if I plot y against x, it's just like plotting Ke max against f. Plot Ke max against f. So that means on the vertical axis, I have Ke max, and on the horizontal axis, I have f. Now, if you compare these two equations, y for Ke max, x for frequency, then m, what is m representing in this our equation of a straight line? This is the slope. That means that if I compare it here, m is just equal to h here. That means the slope is actually h. The slope of this graph will be h. Now, what is c? C is the intercept on y-axis, and that is equal to minus phi here. The intercept on x-axis will also be will be a value here, which will be f naught. Don't worry, all of these things will be done properly when you join us. Actually, I just want to answer this question and move away. Now, if I compare this, it shows that the slope of this graph, will be h. If you compare, and what is h? H is the Planck's constant. It's a constant. It does not depend on anything. It's the Planck's constant. So that means that it does not depend on nature of the metal. It does not depend on intensity. It does not depend on on both intensity and nature of the metal. It is the same for all metals. Option D. If you cannot do this basic math, you will not be able to see it. And that is that about this particular question. So this is what I will this is what you should do. Yes, gradient is the slope. Yes, gradient is the slope, and that's our m. So if you compare, it is the same thing as h in that our equation, which is the Planck's constant. So I want you to go through, I want you to take a screenshot of the remaining question I have here. Yes, as your assignment, look at question 5. Take a screenshot of this now. Yes, look at question 6. Take a screenshot of this as well. Yes, and when you watch the video, you drop the answer in the comment section. Take a screenshot of question 5 and 6. When you watch the video, you drop your answer and let me know. I'm going to look at your answers, and I will also give my own comment. So let's stop here for today. I hope you enjoyed the class. And remember, this is not everything for the course. This is not everything for the topic. We still have a lot of things to discuss, but we can't do that in just 50 minutes or 55 minutes or just 1 day class or 3 days class. We need a proper structure, and we have created a proper structure for you guys. There's a proper structure where you can learn everything you need for UTME, for your JAM, to excel in your JAM, to get that your desired score. I know some of you don't even know your desired score yet. You don't know how to do the math, or you don't know if you need maybe 300, you need maybe 310, you need to do your math with your O level. We are not just going to be teaching you, we are also going to be guiding you along the way. How do you get that perfect score? How do you utilize that perfect score to gain admission into school? Because that is also very important. Some people can get 330 or 340 and waste that score. It's possible. I've seen so many examples. So we are here at Tutoria to not only help you pass UTME well, but also to guide you all the way. So that is why we are here. So you should do the needful. Make sure you register with us. It is important to register with us. We are starting on Monday, and you can't afford not to start with us. We want to start with everybody so we can progress like that till the end of the program. It's not just 1 month program. It's not just 3 weeks. It is from the beginning from next week, which is Monday, till the end of March. In fact, till your exam day, we are still with you. Till you finish that UTME like this, we are still together. So we continue to solve questions, we continue to explain concept. We are covering the entire UTME syllabus. Yes, maybe some of you do not know. We want to cover that entire syllabus and make sure we teach you the exact thing that you need for your exam. So if you want to join us, you really need to join us. You go to www.tuderia.com/UTME. Go there, you register, you sign up, you make your payment, and you'll be onboarded. Then you can start the classes. The classes are going to be virtual. It is not physical. So wherever you are, maybe you are in Abuja, wherever you are, there is no constraint whatsoever. So the classes are starting on Monday. We have 2 sessions. We have the morning session, we have the evening session. So if you will not be available in the morning, you can subscribe for the evening session and you are good to go. So morning session, evening session, there's nothing like, oh, if I do the morning session, won't I miss? No, we are doing the same thing. So morning session, we are going to teach you photoelectric effect. The evening session, I'm going to still teach photoelectric effect. So you are not going to miss anything. This is just for us to account for everybody and ensure that you are all learning, and you are all carried along in this process here. So thank you for joining. Like I said, my name is Green. You can check me out on Instagram, TikTok as Green Knows Physics. Yes, I have made some videos there for you to watch. Some interesting concepts are there already. You can engage. You can share with your friends as well. There's also Lucy Knows English. Lucy as in Lucie. Lucy Knows English on TikTok and also on Instagram. On X, we're also on X. If you are that type that use X more, we are on X. I am on X as Green Physics _ Lucy English _ Dr. Jan Chemistry _ while on TikTok and Instagram we have Dr. Jan Knows Chemistry. So you can connect with us. We have Factoria as well. We have Ayomikun for biology. We are ready for you guys. Just join us and you will not regret this, trust me. So it's really nice to have you guys around. See you in class. Thank you and have a wonderful day.